Hi everyone, welcome back to our channel. Today we are going to solve the below problem shown below. Two identical T sessions are shown below. They are connected in cascade. So this is the T network which is given to us consisting of 10 ohm, 10 ohm, 1 ohm, and we need to find out the Z parameters of this combination. Here you can see here I have been joined. So this is half part of T session. This is another half part of T session. It's already given. They are connected in cascade. Determine the Z parameters of the combination. Okay, we have to find out the Z parameters. So what we need to find out is we need to find out the matrices. Okay, so we need to find out, let's try to write down the equation which will help us in solving the problem. So we need to find out the parameters of Z11, and we need to find out Z12, and we need to find out Z21, as well as we need to find out Z22, which is nothing but these four parameters we need to find out. If you remember this uh, matrix form, we can solve this problem a little bit simpler. Let's try to see here. So first method, I'm going to use my shortcut method of solving it. So here a current of I1 is flowing, therefore the terminals are positive, negative, and the current from this side entering into the 10 ohm is positive and leaving as negative. And therefore, when you apply the Kirchhoff's current law at the node, then you're going to get I1 current is entering, I2 current is also entering. Let's try to mark this current as some Ix. Therefore, when you apply the KCL, entering currents to this node, the node what is marked in red color, the two currents are entering. The entering currents are I1 plus I2. What is the leaving current? Which is nothing but Ix. Therefore, the current here Ix is nothing but the sum of I1 plus I2. Now we need to find out this current. So this is flowing across the branch, positive as well as negative. These two are once again connected in series. And here in this branch, only I1 current will be flowing with the polarity of a positive, negative. And in this branch, once again it gets divided as I2, and the entering is positive, leaving is negative. The net current in this branch is I1 plus I2. So in order to get the standard equations we are going to get from here. So now I'm going to apply Kirchhoff's voltage law at input port. At input port. So in input port, if you apply, already I have been applied. So you see here, current is leaving. What is the polarity of the voltage? Plus V1. So this is plus V1, and current is leaving. What is the leaving polarity? Minus, which is nothing but minus I1 into 10. And whenever the current is leaving, what is the leaving polarity? Minus. The drop is I into R. The current I is nothing but I1 plus I2, and what is the resistance? 1 plus 1, which is nothing but 2 ohms. And once again the current is flowing only in this 10 ohm. The leaving voltage magnitude is minus I into R. I is nothing but I1 into 10 is equal to 0. So directly you'll get the answer. This is applying KVL at input port. And now we are going to apply Kirchhoff's voltage law at output port. Let's try to see here. At output port, if you take, the current is flowing in this closed path like this. So this is positive V1, this is negative V1. Whenever the current is leaving, what is the polarity of the voltage? Which is nothing but plus V2. And current is entering at positive, leaving at negative. At leaving terminal, what is the leaving terminal we are having? Minus, the current is nothing but how much? So minus I2 into 10, and here it is flowing like this, and the leaving polarity is nothing but, so wherever it is entering is positive, leaving is negative, is minus I1 plus I2 into 2 ohms. Okay, so the total current which is flowing in this branch is I1 plus I2 into 2, and in this branch this is nothing but minus I2 into 10 is equal to 0. So here that's very simple, plus V2 minus I2 into, we have to express in the form of V is equal to IR form, all are voltages. So current into resistor. So current is I1 plus I2 into 2 and I2 into 10 ohm. Now let's try to write down in the standard format. Okay. So now I am pushing all these negative terms to the right hand side. Therefore we are going to get V1 is equal to, so V1 is equal to 10 into I1 plus 2 into I1 plus 2 into I2 plus 10 into I1. Okay, so this I am writing. So here I am going to take I1 as common. When I take I1 as common, 10 plus 10, 20, 20 plus 2, 22, which is nothing but 22 I1 plus 2 into I2 is one equation. Next equation, when you come here, you can see here I'm also pushing this negative terms to the positive side. So this very simple to understand. Whenever you have positive polarity, you can understand this is voltage source, the negative terminal or nothing but voltage drops. The algebraic sum of voltage sources minus voltage drop is nothing but KVL. So now this V2 is equal to, I'm writing it as 10 into I2 plus 2 into I1 plus 2 into I2 plus 10 into I2. So here when you are going to compare, so this V2 is equal to, so first term is 2 into I1, this is I2 term, this is I2 term, this is I2 term, plus I2 into, so what are the terms? 10 plus 2, 12, 12 plus 10 is nothing but 22, it's over. So when you compare with the standard, the equations of V1 and V2 are V1 is equal to, what is equivalent? Z11 into I1. So Z11 I1 plus Z12 I2. And coming to the V2 equation, V2 is equal to Z21 I1 plus Z22 I2 is the second equation. So these are the two equations. Now compare the both equations. The values of Z11 is 22, the value of Z12 is 2 ohm, the value of Z21 is 2 ohm, the value of Z22 is 22. So now here I am going to get Z11. Z11 is 22 ohms. Z12 is 2 ohm. Z21 is 2 ohm. Z22 is how much? 22 ohms. So this is our answer. So this is, I am solving it by method 1. This I am going to simplified method what I use. This is a method 1. You can solve it by method 2 also, where you can have more clarity. Let's try to solve it by method 2 also. Okay. So in method 2 is very simple to understand. Let's try to copy our. So now let us try to apply our method 2. So method 2, what is the procedure is, in method 2, what you need to do here is, so first let us make the output port. Okay. So in method 2, what we are going to take is the output port is nothing but I2 equal to 0. Okay, so here we have the equations of v1 is equal to z11 I1 plus z12 I2 is one equation. Next equation is v2 is equal to z21 I1 plus z22 I2 are the equations what we are going to have. So now from here I2 is 0, means this term becomes 0. Therefore Z11 is equal to V1 by I1. You have to find out first. And Z21 is equal to V2 by I1. Okay. So first we have to evaluate these two. So here you can see here output current is 0. I mean this complete current, so the current in this branch will become 0. So how I'm going to replace this? So I'm going to redraw it for your convenience. So this is one voltage source, this is a 10 ohm, and this is 1, and the remaining 1, and this is 10 ohm. So this is 1 ohm, this is 1 ohm. But when you come here, what happens here is, so here current I2 is 0. So current into resistor, okay. So V equal to I2 into 10. So I2 is 0, 0 into 10 is automatically equal to 0 volts. When V equal to 0, then it is called as short circuited. Here, this voltage source act like an short circuit. But here also, the voltage source will try to act like an short circuit. Why? Because V equal to voltage at this point is I2 is 0 and resistance is 10. 0 into 10 is once again 0 volts. That's why this branch also act like an short circuit, and the voltage at this point is V2 and current doesn't flow. Therefore here the current I2 becomes 0. Therefore whenever I2 becomes 0, so this is like drop becomes 0, this voltage V2 will be shifted to this point, or this node will be shifted to this point. So from here how we are going to solve it is, so we are going to, so now here you are going to have V1 with a branch of 10 ohm, and 1 plus 1 is 2 ohm, and this is nothing but I1. So already we had seen that we require V1 by I1. So what we're going to do is I'm going to apply nodal analysis at this point. So how to write down I1? I1 is a current which is flowing across this branch. This is 0 volts and this is also 0 volts. Therefore I1 is equal to V1 minus 0 divided by 10 plus 2. Why? Because these two resistors are connected in series connection. So 10 plus 2, this is how much? 12 ohms. Therefore V1 by I1 is equal to how much? 12 ohms. This is what our resultant is. V1 by I1 is 12 ohms now. So we find out successfully V1 by I1. So next what we need to find out is V2 by I1. Okay. So we need to find out V2 by I1. You can see here. So I1 is the current which flows in this branch, and this flows in this branch, and from here this is going flowing like this. Okay. So from here, the current which flows in this branch is I2, and already I told the voltage has been shifted. So as per this diagram, we can write down I2 is equal to, so I want the current in this branch. So I want the current in this branch with respect to V2. So I2 is equal to V2 minus 0 divided by 2. I require but I require the equations of V2 by I1. So how to, sorry, this is not I2. So the current which flows in this branch and this branch both are same. So this is nothing but I1. So we require the ratio of V2 by I1, bring to the denominator. So this is equal to 2 ohms. This is the, so now ultimately we find the values of Z11 is 12 ohms, Z21 is how many ohms? 2 ohms. Now the remaining also we need to find out. So how to find out? Let us see the remaining two parameters also. So now when you see here, so here we are going to have, we had made output as 0, and we again you have to perform input as 0. I mean the input port is open circuited. If input is open circuited, the meaning is I1 is 0. So if I1 becomes 0, what happens? So when I1 is 0 here and I1 is 0 here, so then what you are going to have is these two parts. Okay. So then when I1 is 0, then you are going to get Z12 is equal to V1 by I2 is one term. When I1 is 0, therefore you are going to get Z22 is equal to V2 by I2. So these two we need to find out to get the solution. Okay. So now let us see here how to apply it. So in this network, so this input port is 0. So I'm going to reconstruct this diagram. So this is one branch, this is another branch, this is the another branch. So here this is of 10 ohm, this is 1 ohm, this is 1 ohm, and this is 10 ohm. So this is the applied voltage V2, and the current flowing in this branch is I2. So here what happens is this current I1 is 0. Therefore the voltage drop V is equal to I1 into 10. So I1 is how much? 0 into 10, which is nothing but 0 volts. V equal to 0 volts means this is short circuited. So the branch what we have here is now short circuited, and here also same, I1 is 0. So therefore the voltage V equal to I1 into 10, where I1 is 0 volts, and this is also now short circuited. This branch completely becomes like an short circuited. And what is the voltage at this point? This is nothing but V1. So the voltage at this point is V1 automatically. Here it is V1. There is no drop. This is V1. This is 0 volts. This is 0 volts. So automatically this V1 will come to this point. This is nothing but V1. Now we require the relationship. Now we require the relationship between V2 as well as I2. So now since this has been short circuited, we can forget this, and this is only the network for us. So in this network, when you see here, so here when you see here, this is only the branch we are having. So this is nothing but 10 ohm, and these two are connected in series. So I'm writing the resultant series branch, which is nothing but 2 ohm. Continue with this branch, this is nothing but once again the 10 ohm. So the applied voltage is V2 and the current is I2. We require the ratio of V2 by I2. So I want the current I2 in this network is flowing like this and coming to 0. Therefore, I2 is equal to V2 minus 0 divided by 10 plus 2 plus is nothing but 22. Okay, but I require the ratio of V2 by I2, bring this I2 to the denominator. So V2 by I2 is equal to how much? 22 ohms. So this is our one answer. But we need to find out V1 by I2 ratio also. So from the same network. So here the current in this branch is how much? I2. The same current will be flowing in this branch. So and why? Because this is forming an closed path. We require the relationship between V1 and I2. So here I'm going to write down the equation of I2 is the current flowing from this branch to 0 here. Therefore I2 is equal to V1 minus 0 divided by 1 plus 1 is how much? 2 ohms. So but I require V1 by I2. So from here I can write down V1 by I2 is equal to how much now? 2 ohms. So now we are going to write down V1 by I2 is 2 ohms and this is 22 ohms. Let's try to verify with our first method. So now we have been got the parameters. Let's try to write down in an diagrammatical manner. So we have been got Z11, Z12, Z21 as well as Z22. So first one here already we have been solved. Z11 is how much? 12 ohms. Okay, and Z12 is equal to how much? 2 ohms. What is Z21? Z21 is 2 ohms. Z22 is how much? 22 ohms. Now compare this. This is we solved it by method 2. Now let's try to compare with method 1. Okay. So you can see this method 1 also is of same. Okay, this is not 12, this is 22. So when you compare both the answers are same. 22 ohms, 2 ohms, 2 ohms and 22 ohms. The answers are same. So you can use either of the methods to solve the problems. Okay. So you can use the first method. We can use the first method of solving directly by applying an 2 KVL, or you can use this method of solving to get the values. Okay, so you can use any of the method whatever you are interested in getting the answers. So answers remain same. So method 1 I think is very comfortable than compared to method 1. I use it to say how many methods are there in solving a problem. If you feel really they are useful, then you can take your decision. So this is not likely by watching the video you get sufficient knowledge. If you're watching for the first time, please like the video, and it's really useful for you. Please share it with your friends, and if you have any doubts, let me know in comment section. And if you're watching for the first time, please subscribe to the channel, and this is a free channel for the beneficial of the students and faculty also. So hope your subscription is more valuable for us, such a way that it should motivate us to do more videos. Yours obediently Ram. So hope you able to understand these two problems. So determining the jet parameters of the cascade jet parameter model. So hope we'll meet in the next video. Thank you for watching.